In this example, I'm going to show you how to solve a polynomial inequality without graphs. So here I have a polynomial inequality. You can see it's not linear because I have an x squared term, so this is a quadratic inequality. So the method here is going to be really similar to the graphing method, which if you haven't already watched that video, go watch that before continuing on with this one. So what I'm going to do is actually collect all my terms on one side of this inequality to get 0 on the other side. So I'm going to have x squared minus x minus 12 is less than 0. And oddly enough, this is going to be a lot easier to work with. What I'm going to do is investigate this polynomial right here. So I'm going to let y equal x squared minus x minus 12. And what I really want to do first is find the x-intercepts, because that's where y is 0. So this is going to separate my number line into different regions and make this problem a lot easier to solve. So what I'm going to do is find the x-intercepts. And remember, the way to find x-intercepts with an equation is to substitute in 0 for y and solve for x. So I'm going to do that here. Okay, so we have different methods for solving this equation right here. I am going to use factoring. So this factors into x minus 4 times x plus 3. And then I can use the zero product rule, set each factor equal to 0, and solve. Okay, so this has two x-intercepts at 4 and negative 3. So what I'm going to do is actually plot that on the number line. So negative 3, positive 4. So these are the places where this polynomial equals 0. But I want to know where this polynomial is less than 0. So what happens is the place where it's equal to 0, here and here, divides my number line up into 3 regions. So my polynomial is either above or below here, above or below here, above or below here. So all I need to do, and it crosses right here, is test a point from each of these 3 regions to determine where it's above and where it's below. And because this problem is focused on less than, I really want the areas where it's below. So we're going to test some points. Now, it doesn't matter what value you choose from this region, but why not make it easy on yourself? Pick an easy number. Now you can't pick negative 3 or 4 because we already know when you plug those in, you'll get 0. What I'm looking for is above 0 or below 0, so positive or negative. So I'm going to substitute in, I think, negative 4. Negative 4 is definitely in this region right here. It's a pretty easy number to work with. So I'm going to substitute that into my polynomial up here. And the question is this positive or negative? So I'll simplify. (20 minus 12 is 8, so this is positive, greater than 0. So on this region right here, the polynomial lives above the graph. Sorry, above the x-axis, right? So the graph will be up here somewhere, it will cross here. Now it might touch and turn and come back up, so I still have to test this region right here. Does it switch to come below, or does it stay above? So I'll pick a point in here to test. Again, pick an easy number. 0 is in here between negative 3 and positive 4, so I'm going to use that number. Again, just plug it into the function. I told you this one was easy. This one is negative. So in this region right here, the polynomial is less than 0. It takes on a negative value. Again, this graph could just touch and turn, or it could actually cross, so I still have to test this region here. Choose an x value that is larger than 4. Pick an easy number. I'll choose 5. Again, substitute that into the polynomial in question to determine if we get a positive or negative value. And we got 8 again, which is positive. So the polynomial is above the x-axis over here. So again, the original inequality was looking for the region where the polynomial is less than 0. So below. So right here in this region. So what I'm going to do is write that solution using interval notation. So from -3 to 4, but not including the endpoints. So to summarize this method, no matter what inequality you're given, collect all terms on one side of the inequality symbol so you can have 0 on the other. Take your polynomial over here and find its x-intercepts. Plot those x-intercepts on the real number line. They are going to divide your real number line into sections. What you'll need to do is test one x value from each of those sections. Choose easy numbers. There's no reason to make this more difficult. If plugging in that test value yields a positive value, then the graph lives above, and if it yields a negative value, the graph lives below. And this will help you determine the solution set for your inequality.